Now let's get something important in circle geometry, the tangent theorem. A tangent is a straight line that just touches a circle at exactly one point. It doesn't cut into the circle or pass through it. It only touches it briefly. In this diagram, the line APB is a tangent and it touches the circle at point P. The key idea is that a tangent is always perpendicular, meaning its speed at 90 degrees, to the radius drawn to the point of contact. So if you draw a line from center O to point P, that's the radius OP, and OP meets the tangent AB at a right angle, exactly 90 degrees. In other words, we say that angle OPA equal to angle OPB equal to 90 degrees. This is super useful in solving problems, especially when you're working with triangles or right angles in circles. Remember, tangent perpendicular to radius and the touching point is 90 degrees. Here's another interesting one for tangents. This time we are drawn from outside the circle. Point P is somewhere outside the circle. From point P, we draw two tangents, one to point Q and one to point R on the circle. Here's the interesting part. These two tangents, PQ and PR, are exactly the same length. This happens when tangents are drawn from the same external point to a circle. It doesn't matter where the circle is or how far the point is. The two tangents will be equal. As you look at the diagram, we call that tangent to the circle means there will be right angles where the tangents meet the circle. In this case, PQ equal to PR, and you see the angle PQO equal to 90 degrees and PRO is 90 degrees. To summarize, tangent from the same point equal to same length. Here's another cool fact about tangent drawn from a point of a circle. Earlier we saw that when you draw two tangents, like PQ and PR on the same point P outside the circle, the tangent equal in length. Now here's another fact. The tangent also make equal angles at the center of the circle. In this diagram, it means that angle QOP is equal to angle ROP. Now the next question you have is why? This is because the triangle form, for example, triangle POQ and triangle POR are actually symmetrical. Both sides are the same and the angles are reflected across the center. So when you see two tangents from one point, you can always say that angle QOP equal to angle ROP. Now, here's the last concept related to the tangent theorem, and I believe some of you have seen this coming. We just now learned two key facts about tangents from the external point. We know that the tangents are of the same length and that they make equal angles at the center. Now, here's the last piece of the puzzle. The line from the external point to the center of the circle actually split the angle between the tangent perfectly in half. In this diagram, you'll see that point P is outside of the circle. We have line PQ and line PR being tangent. The line PO draw the external point P to the center O. Now look at the angles at the point P. Angle QPO is equal to angle RPO. This is because PO is the angle bisector. It cuts the angle between the tangent into two equal parts. You should not be too surprised because just now we already know that angle PQO is 90 degrees, and we know that angle POQ equal to angle POR. Since the sum of a triangle is 180 degrees, it's only logical that the last angle, angle QPO, will be equal to angle RPO.